things that are in both pre-midterm. So I was just, for those joining us from the ether, I was just describing about, I expect about 33% of the final exam to be on pre-midterm material and about 66% post-midterm. And there is some material that's in both. Some topics that stretch across both. And I would highlight regular expressions. Where do we see regular expressions post-midterm? Yeah, because that's what it said. So Regex, I would expect that. And with the set discussion, we particularly drew on some grouping abilities of regular expressions. What do we know that is the capacity of regular expressions to delineate certain regions of the pattern as things we memorize, so to speak, right? So we had, certain elements that might be remembered and for later reuse. So we might look here for something like that. What is this? What is that regular expression? That's a lowercase w. What does that regular expression mean? What set of characters? This is a 1 here at the end. Okay, good. So that means white space actually. So it could denote a space. It could denote. So if I had this expression, this is what I've just written on the board. Forgive me, I'm just typing this in for people who are not able to be here. If I had this expression, so that's space or white space rather, the \s. Good. So if I had this expression, what would it match? What is lowercase w? Sorry? A word character. How do I denote a non-word? Yeah. Capital \w. So this would be a word character followed by I'll make it plus here. Followed by one more spaces, white spaces, I should say. And here we've got a word character inside the parentheses, and then one more spaces outside, and then \1. So what's the job of these parentheses? Yeah. It remembers this and matches that same exact string. Whatever match here within the parentheses, it's going to demand at the end of the expression as well, right? So if you had John Doe Doe, that would be an unappetizing name. If you had John Stewart Stewart, then that would match that sort of regular expression, right? So these grouped elements, as indicated, denoted by parentheses, they can be remembered and then they can be used in the same expression. Where else can they be used instead? In the replacements, right? So if you do like slash this by this, then basically we will be replacing John Stewart Stewart with Stewart. Yeah, exactly. That's something which came up within the set context as well. That's one thing that has some continuity between the two components. Another thing, we actually talked about some shell commands, although they're mostly covered in either one or the other. But we certainly had some commands that were covered early on. Some common shell elements, and some that were covered later. Right? So we had things like diff and things like word count and things like cat and things like more and less and all those sort of good things covered in the first half. And then in the second half, for example, we had find in there. One of the things I talked about, this was in a review session, this wasn't in class, but it did appear in a little bit of material, and it's worth you knowing about, was push D, pop D. So push directory and pop directory. So you can, some of these shells support this directory stack. Push D, your current location, your present working directory will be pushed onto this stack, which you don't really see, but which is there, accompanying you, following you around, your invisible friend. And you can then do CD and go around the directory space, and then you can say pop D, and you'll be back at that same place where you've last been placed. So that allows you to kind of do subtasks where you're in the file system space, and you're kind of navigating around, but you know that you really want to come back to this place that you're currently at. So maybe this is your home directory or something, some common place you want to come back to, and you go do some searching things beneath it or whatever. But you know you're going to come back. You're going to come back to the mothership. You're going to come back home. So you can do a pop D then. So you do push D here, just a second, and then a pop D after you've kind of done your explorations, and suddenly you're back to the place that you were at when you did the push D. That's a really useful one, not sort of by all shells.
Yeah, but push doesn't actually change with you. It basically stores whatever directory you want in memory, and then you can pop back and pop.
Yeah. No, absolutely. Thank you. The pop D changes where you are currently. The push D just records where you are. It saves that information where pop D not only pops the stack, it puts you back at the place that's at the top of the stack. Yeah. So that is a side effect. Pop D, so teleports you back, boom, to the place that you were at before, and when you did the push D, teleports you back, and it also pops the stack off. So the next time you say pop D, you can go back to the next thing that's on the stack, right? So that's good. Okay, let's get other questions. Yeah.
That's on bash, but this is what other shells. You know what shells.
Yeah. Trying to remember. There's at least 2 of them, and bash is one. And I'm trying to remember. Wondering if it's SH that does that, but I don't think so, because I think I've tried out in SH and been unable to do it. So I'd have to get back to you on what the other one is. I would have expected to be SH, but something else tells me that's not the case. So you can, if someone wants to try it out, you could tell me. It could be TCSH, although that's a different shell lineage, so maybe they borrowed the idea. But it does appear in a couple of shells. Yeah.
Just saying, when you're already in bash, you just say bash puts you in a new shell.
Correct.
The exact same directory that you.
Correct.
It's not the exact same thing.
Because
when you just exit, it's just like popping.
Great. Great. Okay. So that's a great question. So how would pardon me while I'm just getting this set up. How is it different to say from push D and pop D? How is that different from the world is analog? Okay. Maybe not. Okay. This is not going to be very helpful. Okay, I was hoping to display this, but I think we're. I know you folks would probably like to see me crush myself into this cabinet, but I think I'm going to spare you that amusement. So how is it different, the push D and pop D? So I'm gonna be typing things on my computer that are for the remote audience, and things on the board for you, and I'll try to kind of keep them in sync manually since I can't display here, okay? So how is pushty-pupty different than saying bash? Okay, when you say bash, what happens, folks? Starts a new shell. And one of the things that's nice is, yes, you start in the same location, so your location doesn't change. And then you can do whatever, and then you can say exit from it, right? And you'll be back to your outer shell, right? Back to where you started, right? It's a little bit like that, but something else goes on. When you create a whole new shell, first of all, a whole new process is started. A whole new process started. And second of all, any changes to shell variables that you make there, you won't be seeing back in the original shell. So you lose other information as well. I mean, you're right, you could do it. It's kind of a neat hack if you don't have anything else to do in that shell. But if you're maintaining shell variables or maintaining some other information, your history information, we didn't really talk about this in class, but some shells, we alluded to it. Some shells allow you to maintain history. You can do, for example, bang bang, and it will repeat the last command that you did. So my last command was ls minus l, and then maybe I go off my text editor. So I type ls minus l in the shell. Then I go off my text editor and I save off the file. And then if I want to do another ls just to see if things have been updated, I can do bang bang and it will repeat the last command. I can also do, it turns out, bang and a number for a certain number of commands to go, or I can do bang L or the last one that had that started with that letter. So shells allow you to keep history information, and that would all be lost if you left that shell. So if you go into a whole new shell, and you release that shell at the end of the time you're done, it's true you go back to where you started up the shell, but you also lose some stuff along the way. So it's not quite as fine-grained. It's not quite as sort of finessed as doing pushty-pupty, which only basically deal with your location file system. Does that make sense? Yeah. Good. So other questions. These are great questions. They're great questions. So what other questions do you have? The main topics?
Yeah.
Oh man. Okay. So I'm going to rattle some off the top of my head and be sort of calling up a something here which will probably alert me to more here. So very significant topics for the final exam would include subversion. Would include the use of makefiles and generally version control mechanisms. It would include a glimpse of shell scripts. We saw that a little bit in that last day. It would certainly include utilities like sed, how that works beyond the regular expressions components, and find, which I talked about. It would include use of GDB and debugging as a general sort of element. It would include elements of clean coding, which was not included on the midterm, although we had started to cover some aspects of it. That clean coding elements include some discussion of idioms, right? So idioms to recognize things you do, instead of a for loop where in the body, or instead of a while loop where in the body you have I plus plus, you have a for loop, you know, I equals 0, I less than, not less than or equal to, but less than 10 I plus plus. And if you're in an array that's less than the length of the array, right? And we talked about some of the issues with good variable names. We talked about issues with indentation. So, ladies and gentlemen, people seem to like stories. And it's one of the points of feedback I got. So I was just last Friday, excuse me, God, no, it was Tuesday. I was just a few days ago, yeah, Tuesday. I was with a student trying to debug a problem up in Sphinx, actually. Wasn't a student in this class. But the student was staring at this code, staring at it. And it wasn't working. And they would say, no, sure working. I went and I looked at the code, and it looked all fine. The logic was quite pristine and clear and so on. And so we kind of fought with it for a little bit, and then it all came down to, you know what it was? Well, the student had, you know, if this sort of thing, and, you know, this thing. And guess what was missing? Yeah, the curly bracket. And so, you know, to the student's eyes, to my eyes, like, it was reaching the point, of course, it's got to be reaching all of these. You know, it's got to be reaching everything inside that was indented under that if statement. And it wasn't. It was just, let's put it this way. If this was not true, it was still executing some of those things that seemed to be indented under if. They seemed to be in the consequent, and instead they were after the if. And, you know, we had looked at it for quite some time. I had looked at it for, you know, a fair bit of time, and we didn't see that immediately. It was only until I kind of looked at it that it went.
I put a semicolon in and I was wondering why wouldn't it happen?
Yeah.
I put a
The semicolon.
So it wouldn't even start.
Yeah. Yeah, exactly. Or, you know, another classic one is you have a while, and you have a semicolon here, and you have these things under here. And
Yeah.
what does that mean in C? What does it mean if you have a sort of a while, you know, while foo, and then you secretly have a semicolon, but then you have a sort of bunch of code inside of curly brackets underneath it. What does that mean? And then execute whatever this block is. This is just a statement code. All the curly brackets mean is just a compound statement. It's a statement that consists of substatements. That's all it means. It's a statement. And because it's one statement, it can go inside an if in the consequent, or inside the else clause if the so-called alternative. This is just a statement, and so it just happily goes down and executes this thing. It's a useful type thing because you can have definitions of variables inside of this. Right up top, you know, you can have int bar equals 1 or whatever. But the point is, it's just a statement. So it'll first wait for that while thing to finish, and then it will only then execute the code. And that code is not inside the while loop. It's outside. It's after the while loop. It just looks that way to the inside. So indentation is important. Another trick we talked about, which can spare you grief, is having, if you're going to be testing the equality between some quantity, maybe it's a variable called bar, and some constant, how do you write that? So I'm going to have if, yeah, so you put the constant on the left-hand side. Why do we do that? Yeah, exactly. So you don't set bar because in C, one of the most common mistakes you see is people forget the second equals. And this way it'll warn you. This way it'll say, that doesn't compute. Instead of having if bar equals 1, in which case it'll just say, oh, if 1, basically. It'll set bar to 1, and it'll use the value 1, and it will say, this is true. And it will go on. That's uncomfortable because it's silent but deadly. Silent but deadly. Okay, so so that's another idiom. We talked about quite a few little idioms like that, little principles of clean coding. But we also talked about the issue of, by advancing it, and I used the term functional abstraction. What does that mean? Yes. Yeah, exactly. Breaking it up into parts. So one of the big reasons you don't have to look at it all at once. So it's out of respect for people, right? They don't want to necessarily see the gory details of everything that's going to happen as part of your code. They want to see sort of at a high level, okay, what's it doing? And if they want more detail on a certain piece, they can get it by going and looking at a function that does that thing. But they don't have to. They can get a gist of what's going on and figure out, do they want to see more detail or not? Maybe they're in the middle of debugging. You don't want to show everything, all these things that are going on, every little gory detail. Instead, you have calls to functions, which are nicely named, and if they want, they can step into those functions with the debugger. Otherwise, they can just step over them. Why? Because in that GDB, remember that? You can step over a function call, or you can step into it. And it's really useful to step over it. But this can help other things too. You can have your friends, different of your friends, implement different of those functions, or if you call it, it's more like the professional development setting. You could breaking up into functions aids what? It aids debugging, it aids clarity, and it aids, begins with a T, ends with a G, testing. It aids testing. Why does it aid testing? Exactly. It's not a big hairball, folks. It's not all twisted together and everything's intermingled with everything else that a test one thing if you test everything. That leads, as they say in King Lear, that way lies madness. Instead, it's parsable out in pieces. You can test each piece, and then you can start to test how they work together. But that ability to test each piece lends confidence that the different elements, the building blocks, are individually working. It also helps in the debugging of it, because you can set a breakpoint, right? You can set a breakpoint on a function. You saw how that's done, right? Pow. You can set a breakpoint on it, and you could go to that breakpoint. So it aids that as well. It aids clarity. You look at the function code, and you look at it's a little small. You look at the arguments of the function. You know that sort of parameter button. Parameters is what it's called. The things it takes in as input, and you know what it depends on. That code's just all in front of you. You can't really tell kind of what depends on what. What is this code? What does it depend on outside of it? With a function, it's all given right there. Okay? It's given right in the header. It's given as the arguments to the function. So you can look, oh, this thing takes a double value called v, and it takes a tolerance called TOL, and those are the things that depends on outside. Otherwise, everything is defined within. That's a really great thing. So dividing things up into functions, it lowers the clutter. It aids in testing. It aids in debugging. It aids in clarity of it. It aids in dividing it up into pieces. So when I see you next year, folks, and I hope I will, in some of my classes, maybe even next term, just remember that admonition. There's actually a video of me. If you folks want to see it, I'm happy to give it out. There's a video of me reviewing code from other sources, and it shows my reaction to page after page after page of intermingled code with user interface stuff mixed in with core logic. It's just horrendous, and the students had no shortage of mirth watching my reactions. I'm a man who keeps my language clean, and I needed to exercise profound restraint in my vocabulary during that session. And I think I may have, in fact, broken down at one point and made some utterances that prevented the video from being properly shared with the whole world. So anyway, it was a difficult situation because the code was really crafty. It was really, all mixed together, and it was abusively repetitive. This is a bad smell. We did talk about bad smells, and those are things you should know about. So what's a bad smell? Why do we care about bad smells in code? Yeah, that's right. So maybe right now it's all, in the best case, maybe now it's bug free. There's reasons to doubt that. Often they're hidden by the leak bugs. Maybe that's the cause for that intermittent crash of your program 100 times. It's not a cosmic ray. It's a bad smell. But bad smells often point us to places. If we look at bad smells, those are often where the bugs breed. That's where the next epidemic of bugs will come. That may be the area that will keep you up late at night for the next thing. Today's risk becomes tomorrow's emergency. And if we look at bad smells, often they clue us into the breeding ground for bugs, and they clue us into the risk for understanding to someone new comes to the code they want to understand. So give me some bad smells in code. What are some things we look for to say, oh, that code, what sort of things would give me the heebie-jeebies and make me exhibit uncomfortable responses? Okay, yeah, deallocation willy-nilly. Deallocation occurring just with no rhyme or reason, just plot in place. So that's asking for trouble. So that's good. I like that, and that's actually the knowledge. What other things would give me cause for worry, or give me worry, or give me cause for concern? Sorry? You mistake my aesthetics, young man. Actually, incrementing a pointer, by in and of itself, can be argued to be a thing of beauty. Well, okay. It at least merits respect. And if you folks are going to deal with C code, incrementing a pointer should be something you're comfortable with. And if you're not, I would urge you, regardless of whether the class is in session, to come talk with me. If we have an array, this could be an array, ladies and gentlemen, of ints. Maybe each, well, maybe we'll make it at first an array of characters. Maybe each of these is a byte, right? Right? Okay? And let's suppose we're in a situation where character is a byte. So this is a char star with some p, and it points to this thing. If we have this thing, maybe this was something that was allocated by malloc or calc or by new with a character array, right? And if we have p, if that's where p points to this first element of the array, we do p plus plus. Where does it point next? The next one. And p plus plus again. Third one. Okay, now the risk, and perhaps it was to this that the young man was alluding. The risk is this all looks fine until what? Until you get to the end, and then it's kind of like you fall off the end of the earth, and you're pointing off into space, and you may be pointing at things that you have no business pointing at. You may be pointing at arrays of doubles. You may be pointing at file handles. You may be pointing at deallocated memory. And if you start frobbing that, if you start assigning things into this, bad news may happen. Let me ask this, though. I want folks to be actually pretty comfortable with this. And again, I would invite you to come to my office to have discussions about this if you're not comfortable. Now imagine a situation where we're dealing with ints. Okay? Maybe I'll draw it over this first one. And I apologize sincerely to our remote colleagues here. But I'm drawing an array over this first array, which the first array of bytes, one after the other, arrayed out. Now, what would an array of ints? Let's suppose that ints are 2 bytes long. What would it look like? Where would the divisions be? First division is here at the same beginning. Where would the second division be? Yeah, it would be there. It would be sort of like after every 2, right? And then it would be there, and then it would be there, right? Now suppose I have an int pointer, folks. So I'm going to call this first one pointer to a character, PC, okay? PC and a PC++, PC++, right? Okay, now suppose I have an int pointer, and I'll call it PI, right? PI. Suppose it points to the very beginning of this array. If I did PI++, where would it point to then? Oh, yeah, thank you. Yes, quite right. Pint, pint, what's that? Well, often we name it so P in the front means it's a pointer to something. So, sorry, I'll call it PINT. And now suppose we do PINT++, okay? Pointer to the n plus. Where does it point to now? It points here. It knows to increment it by the appropriate amount. That's why it's a pointer to int, so it's advancing int by int by int. Okay, that's the important salient difference between a pointer to character, pointer to int. Now, I don't want to scare you folks, but I'm going to tell you a secret in a few minutes that may that may unsettle you, but it may liberate you. And so we'll get to that. So how if I have an array? How if I have a pointer to doubles? Actually, say these are floats. A float is it 4 bytes? A float. So every 4 bytes. So now we have these floats. 1, 2, 3, 4. Roughly there. 1, 2, 3, 4. So here's the next. Okay, now we have a pointer to floats. We have a float pointer. Imagine they're 4 bytes. P float. Okay. Maybe you don't like that one as much. Now, so we have a pointer to this guy. Now, how if I say, yeah? It's a good question. They are in C. You can do it with array indices for the most part, except that there are certain things that you may wish to do that an array index won't give you the requisite flexibility. So one thing you can do is you can cast a pointer from one type to the other, and it's that secret that I wanted to show in just a minute. Okay. Okay. So here's a p float, and if I increment a p float, if I say p float plus plus, where does it point to next? Right. Yeah. So it all works. There's nothing terribly unholy about incrementing pointers. And by the way, we say p int plus equals 2, and we'll skip 2 down there. That's fine. Now, one thing though you could do with pointers, you could say, and this is where some people delight and other people's cringe. Okay, you could say int star p int equals. I'm going to cast this character pointer to an int pointer, and now I have a pointer to this character array. Sigma is built as a character array as if it's an integer pointer, right? It's the same memory. It's just I'm treating it as if it's integers. Why might I want to do that? Well, in C, I might read into that character array I might read into it a bunch like from a file. So I read it in as characters, and I stick it there, and then now I want to treat it as integers. That's legitimate. It's nothing terribly wrong about that. And C gives you that ability to kind of very easily go between these views of it. You can sort of cast it easily and et cetera. So this is something that does allow you to do that. But some people will feel strongly that, firstly, I feel that, you know, I mean, I'm really glad that there's no pointer arithmetic in Java. Because you can do enough with arrays that it's fine, and you can avoid getting yourself in trouble. Because this gives you so much flexibility, you can, again, cut off your leg with it, right? You could say, these are a bunch of doubles, but now I'm going to treat them as if they're structures, and I'm going to do weird things with them. And suddenly the double data doesn't make sense. It's nonsensical. You've done something that can't be done with a double. But C lets you do that. So, but there's nothing terribly unholy about pointers in C and pointer arithmetic. It just needs respect. You need to do it in a very careful, disciplined way. Know what you're doing, make sure you're not going beyond the bounds, and know the risks associated with it. Another risk, by the way, would be you increment this pointer, and then you try to free that. You try to delete that. Now you don't have a pointer to the beginning of an object, you have a pointer somewhere inside of an object, and you try to delete it, free it from the heap, and the heap's going to go, well, if you're lucky, it will say can't do, but if you're unlucky, it will just do something silently, corrupt the data, and get all confused. So yeah, you got to be careful with pointers. But what are other bad smells? Things to watch out for in your code that are things to cause for work. Yeah, monolithic bunches of code, page after page. Great. Especially that YouTube video has me reacting to code where, like, most lines are almost exactly the same as the previous line. It just had like one or two little changes. So I have the same long, complicated string, and let's say, you know, at the end, plus, meaning concatenation in Java, plus A. The next one will be that same very, very, very long string, plus B. The next one will be this long string, plus C. Or it'll just you know, print out the same thing exactly several times instead of having a loop or something like that. So repetitive code, this is another big one. What's another thing? It's a bad smell. Inconsistent formatting, so no indentation, poor indentation. Indentation that's inconsistent, that's good. Another thing, naming. We talked about that. Don't minimize the value of names. You may dismiss them while you're writing the code, but believe me, if you come back to that code 3 months later, gosh, maybe I should hand out part of the exam. I could give out like your first assignment, give out your first lab or something like that. And each person could fill out and then answer questions. And that would be a learning experience. So names are really important. They help you remember, like, what does this mean? Names are extremely important. We talked about some other ones, but bad smells in code are a really important sort of topic that I might want to ask you about. What other things might be as sort of broad topics on the file? Oh, assertions, exceptions, and errors. Assertions are used for identifying logical coercions or sanity tests. They check our assumptions. They check things that are under our control. Should never be the case if we're saying the programmers are operating properly. This should never be the case. What is an exception handler? Rare things, things we can't control. Yeah. So give me some examples of rare things that we can't control. Out of memory. great one. How about another one? Sorry, no confidential server. Other? Yeah, network outage, okay. Another one? You can almost fill in out of disk space.
Yeah.
Network congestion, out of bandwidth. You're trying to send off data and then or get data and it's coming too slow and you get network timeouts. You can have problems associated with particular services failing. You can get disk corruption. You can get situations where a file can't be found because someone removed it or something like that. These are things, ladies and gentlemen, we don't control. These are aspects of the world we gotta handle. And you can't just put an exception and say, you know, hasta la vista, baby, if this thing, you know, doesn't get this wish of ours doesn't get granted. You can't do that. That's not showing respect to the user. And if you just bomb out of there, you may lose a lot of valuable work. Instead, you gotta say, okay, we gotta deal with this situation. Maybe it means freeing up a bunch of memory for things that are less important. Maybe it means putting up a graceful message, writing what we can to disk, and leaving. Maybe it means warning them that there's something wrong, you know, that a file is missing, or that the disk is full. At least doing the respect of giving them some message before leaving, not just showing them the stack trace, as you might get for an insertion failure. So exceptions, they provide a way to sort of delegate, say to my superiors, hey, could you handle the situation for me? Something really bad has happened. I don't have control over it. Please handle it. So out of memory is a great example of that. You can't just say assert there's memory because that's just a wish. It's not a reality. And we could feel once again that we should be given more memory, but that's not going to be very effective, especially if we bomb out and the user doesn't even know something's going wrong. Okay, what is going wrong? So an exception is for rare things. Why rare? They're costly. Quite costly. So for things where we need lightweight indication, what do we use? What's one good thing to use? Return codes, return values. Those are used in Unix a lot for command returns. When you have a command and it succeeds, what's the return code? 0, actually. Yeah, it gives C program a little bit of pause. Ooh, I'm used to using that for success, but it's actually 0 is the success, and something with non-zero is a return code of some sort. What's really nice is if we don't return integers, but we return a named value of some sort, like in Java and C++, we have what are called nums, and they appear in many languages. And that gives nice code for each way. Exceptions, meanwhile, allow you to wrap up all sorts of custom information with the exception. You can wrap up information about what line of the input file I couldn't understand, or what time was it when this occurred, or what was it in the middle of, or a custom message. Return codes are more limited. You could, in principle, return to a structure that has some quite sophisticated information. But return codes are kind of a lighter weight mechanism. They involve less application memory, and they involve less maintaining stuff on the call stack. Indeed, call stacks. Call stacks. We talked about them a little bit in a previous review session, so I won't go over them in detail, but we talked about how you can call successive functions, and so I'll draw them this way. Foo draws bar, draws baz, draws app, but it's not predicted privileged. I like to think of it as sort of going up, get piled on there as each new plate gets piled on, but we could draw it this way. So here's a call stack, right? Where did you see those? Yeah, in GDB, you did a backtrace, right? Backtrace, and backtrace full, and you could see this call stack. And in fact, you could interrogate particular items on this call stack. So you could, if there's an A here and an A here, you could say, you know, let me be with respect to this frame and ask about that, right? Okay, so that's good. So exceptions, return codes, and assertions. Those are all key things. The whole idea of automating the builds is important. The notion of debugging in a way that forms hypotheses, goes to investigates, collects observations, and ladies and gentlemen, simplifying your input, simplifying your program, make a copy of the program, copy the input. Simplify, this is not a spectator sport. You roll your sleeves up and you start, you observe and you try to simplify the situation as much as possible by simplifying that input, seeing what you can take away, and still the error occurs. Start giving you hints about where things might be occurring. And moreover, once you have a clue about where the failure occurs and have a simple way of repeating it, you can then rip away pieces of your program, or copy your program, of course. Copy your program, rip away pieces of that, see if is it still occurring? Is this problem still occurring? Is it still occurring now? Is it still occurring now? Your program's getting smaller and smaller and smaller and smaller. And you are honing in on that source of the problem. You're getting more and more clues as to where this problem might be. Often we can do a lot just with printf statements. Debuggers, they're a luxury. I've done more debugging in my life with prints and having it have some indication than I have with debuggers. Debuggers I use a lot. Spend a lot of time with debuggers, but they're kind of the heavy artillery you drag out when it's a little bit more of a thing. You can do some prints and see what's going on in a pretty quick way. You call it the debugger if you have a memory fault or a segmentation fault or a null pointer exception and so on. The debugger can be great. Look at the stack, cats meow, and being able to interrogate variables. But often you can get a lot just by some simple prints. Yeah. GDB is extremely widely supported, and pretty much any system, certainly any Unix system you go to, you'll find that. Modern graphical debuggers, they are large in number and they're extremely popular for good reasons. Examples would be, the debugger that comes with Eclipse, the Visual Studio debugger, Code Warrior, IDFJ, any number of different debuggers, and they're terrific. Graphical debuggers allow you. What I really like about graphical debuggers is they allow you to visually see, for example, a set of watch points or a set of variables you're kind of looking at, and see when they change. See kind of when you hit a breakpoint, what are the current variables? Just let you glance at it and see. You can do that in GDB. How? How would you get it? Every time you hit a breakpoint, it should print out the values of variables to you. How do you do that in GDB? Yeah, so you can ask it to display, right? You can say like display, and by setting it to display, every time you hit that place, it will print these things out. So display P, display A, display foo, or whatever, and when it hits it, when it stops, actually, it'll print those things out. That's really great. But with a graphical debugger, you can see these things. The call stack can be visible at all times, to your eye, and you can actually explore interactively, expand structures, etc. It's really nice. And I think it provides just an edge in usability. But I have to say, after having spent a huge amount of time with graphical debugging, GB is still pretty darn good. It's still pretty nice. It's the old trusty feeder truck that you drag out, and when you need to get things done, and it serves the purpose. It ain't pretty, but it does the job, and it is super widely supported. It's like imagine you have a beaver truck in every corner of the city. go load that soap at the back. So it's really common and extremely well supported. Similarly, GCC, the new compiler suite, G++, GCC, extremely widely supported. All sorts of versions of it for compiling for different things. You know, it's probably ported to hundreds of architectures, different things, and so it's a great thing. And if you know GDB, I'm sorry, if you know GCC or G++, you know it on one system, you know it on another, you know it on another, you know it on another. It's not like Visual Studio where you're stuck on x86 systems, or you know IDFJ where you're dealing with you're going to a very commonly needed system, and GDB is sort of by default you could just use with GCC. So, graphical libraries are even better yet, and some of them have dynamite features, but GDB is that trusty leader card. Okay. Questions? These are great questions. Question? Okay, I can continue my sort of stream of consciousness here. Okay. Don't mind if I do. Okay. So let's look at some other things. Well, in Subversion, I mentioned that will be tested. Ladies and gentlemen, I do expect you to know basically which Subversion commands you use for what sort of thing. Not with the exact syntax, like what order the things in, which expect -n or whatever. But I do expect you to know basically like what's the difference between SVN update or SVN checkout or SVN import or SVN admin for setting up. You don't set up a repository with just SVN or SVN admin for it. I want you to know about things like SVN resolve, in fact, or SVN, SVN commit, certainly. And I want that conceptual model to be crystal clear with you folks. That, by and large, you're just operating your working directory. If you do SVN add, or you go and change the file, in fact. Or you are editing a file after a failed merge. Those things only become visible to others when you do and commit. Of course, commits succeed. And commits are atomic. Commits are they occur all together or not at all. These are extremely important. And we talked about this in previous people. There are recordings of me talking about this. But those are extremely important things in the Subversion side, okay? But would you like me to continue my stream of consciousness on major topics? Because these are very likely, you may think that I exhibit non-deterministic properties, but that is true. But a lot of these things I rattle off, believe me. When I sit down and I'm thinking about, what exact questions you have, these will be coming up again. These things. These are major topics. These are things I care about greatly. Okay, so I do want you to know how to resolve something, a conflict. Yeah, we talked about test-driven development. This whole notion of writing the test before the code. The test that first should fail. They should fail before they succeed, right? Fail, we write the code to make them succeed, right? Now they succeed, now we write another test that, if we're lucky, we didn't think it through, and oh, it actually succeeds. Our system actually meets that. Oh, great. Oh, it's sweet. Now we go and write another test until involving a new feature. Oh, it doesn't work, and our system doesn't satisfy it. No, we expand it, and then you go through bouts of what's called refactoring. What is refactoring? Yeah, without changing the functionality, without changing what it does, it improves it. Without changing the contract, it improves the code in some way, non sort of way. So it may improve performance, transparency of it, how flexible, how extensible. Oh, and by the way, folks, I didn't mention these earlier. Flexibility, extensibility, functions, good. Having these things broken into functions, you want to extend your system, all the things that need to do logging are calling the same function. So you just go and you change that function instead of having to change your code in 100 different places where it prints out long messages. It's all in one place. So extensibility, wrapping things up in functions is really good there too. So refactoring is about sort of cleaning it up without changing how it works. It shouldn't change whether it succeeds or fails with respect to tests. It's just changing, it's purifying it, it's investing in it in terms of generality, flexibility, etc., all these other non-functional elements. So we talked about test-driven development. We talked about contracts. We talked about, and this is really important, documenting the what something does. And separating that from how it goes, separating from the implementation. I want people to know you're going to give them something. You're going to give them a service agreement, contract. It's going to guarantee certain things. They can count on those things. But it's up to you to figure out exactly the details of how to do it. That's your business, their business. There's certain guarantees you give. And your guarantee is you won't change those things they're counting on. You know what they're counting on, because that's part of their contract. They know what they can count on. And it gives you flexibility to modify others. Right? So when you divide things up into pieces, even if that piece isn't written yet, people can write code that uses it. That may sound odd. Let me repeat that. If you have foo calling bar, and they're in separate functions, even if bar isn't written in, you can write foo. What a horrible name, but you could write whatever this has to do, because it knows what bar does, and so it knows, okay, you have to pass it a non-null pointer, and it returns something with guaranteed to have these properties, whatever. It knows what it does, and so you can write the code for foo while someone else is writing bar, right? Or you can do mocking, or what's called stubbing. So when testing foo, you could do so with a what type of version of bar? It's a stub. It's a fake version of bar. It does something really simple. Maybe it just returns a fixed value. Always returns like that. Or maybe it does something better than that. Maybe it checks the values of things passed to it just to make sure they're the same, right? The things passed to it by foo match its needs. Yeah, you can do that. But the point is that we can focus on testing foo against known things out here. We don't have to worry that bar is going to screw up foo, right? And then we could have it actually called real bar. So the point I was making in terms of the this issue of the testing and the notion of investing in your code by breaking things up into pieces with functions is an important, very important element that ends up affecting this sort of ability to do quality assurance and piecewise testing in these programs as well. So this is one element that we saw when talking about separation of interface from implementation. By separating these out, by dividing into separate functions, and by providing a contract of what bar does instead of having foo depend on the exact how. We have the flexibility for bar to be evolved by the people who created that, but foo, the creators of foo know with confidence what's guaranteed to be stay the same, what's guaranteed about bar. So that allows more easy separate development. It allows, it goes along with breaking into functions, and it goes with testing, etc. It provides us some ideas of what to test. So the separation of implementation from interfaces later, you folks will see, you probably didn't see this in 270 interfaces in Java. Oh, you did? Okay. Okay, that's wonderful news. So there you have an interface, and it just says, oh, you know, something which matches this contract. We'll call it whatever. And there can be many different things that match the contract. As long as they match them, I know how to deal with them, right? Do you hear the term polymorphism or something? Yeah, okay. My hat's off to you. That's great. So the separation of interface from implementation is a key part of this contract, of this course as well. Side effects. Oh, yes. Side effects. What's a side effect? I said, I called this function and had a side effect. What do I mean? Yeah, change. There's something like sort of state. Something I didn't expect often is what it's referring to. It kind of did the thing I wanted. It returned the square root of the number I gave it, but it changed the global variable as well, or something like that. Changed the global precision. To be a side effect. Another side effect, we actually printed something out. It had some visible change associated with it besides just computing this out. Ladies and gentlemen, when we have bits of code, when we have functions, often we try to segregate them, separate them into two types of things. One that computes values, but it doesn't have side effects. It just returns a value, calculates, returns value. Now, internally, it might, don't get me wrong, foo can call bar, and bar inside of it could have variables and modify them. It's just foo can't see those changes. Those changes are invisible to foo. It's not something that's changed outside of itself. So I can have all sorts of stuff going on, but it's not something you have to worry about. It's just something going on in my belly, something like that. So bar can have these things going on inside of it, but as long as foo can't see them, they're not a side effect as far as foo's concerned. It's not an observable change, right? So foo can call bar, and bar can compute some values and then return the value. And as far as foo's considering that's had no side effects. It just computed a value. It performed a service and computed a value. It didn't change anything. It did a calculation. We have different words for it. That's one type of function I talked about. But then there's a separate type of function that's actually often given the name like perform, update or something like that, or do update, and or print, print report or something like that. It's an action associated with some notion of change. It actually goes and does them. It doesn't compute. It doesn't do any fancy calculation, unlike the first one. The first one might compute the value of pi at 37 digits, or it might, the very first one might, so this type that just does a calculation, it might take the square root, or take the cube root, or perform some simulation and return the results, or something like that. But it doesn't change anything that's already there. The second type changes things. It updates the screen. It has a side effect. These are the side effect ones. These are things that have a side effect, but they have a pure side effect. Pure in the sense there's no calculation occurring. So we separate the two. And it means that when we want our calculations, we don't have to worry about side effects. We don't have to worry that getting pi 37 digits will send a message to my mother. Or it will say, ain't that pi good? Or it won't go and update my screen. It won't put something on disk. This eases testing, ladies and gentlemen. Because maybe in our test we want to call this thing with pi many times, and I want my mother to get a message every time, as much as she likes getting messages. We can test things again and again because it just performs the calculations. We can call it again and again and again without having to sort of do lots of things to wind it back so it's in a repeatable state. Just call it again and again. It's the same thing every time. So separation of things with side effects from so-called pure functions that just calculate things. This is a good principle. Part of clean coding. Yeah.
Are we going to have to really know the process of compiling?
I mean like GCC minus C type of thing?
Yeah, kind of that's where like that.
So I do with make files, and I have a fairly articulated discussion of this in our last review, so I don't want to plug it right now, but I will expect you to know some basics, so I can rattle a bunch of things off here. I do expect you to know about targets, dependencies, actions. I do expect you to know use tabs, not spaces. I do expect you to know that you can create that you have these abilities to create these macros, which can be used to denote sets of values. Most importantly of all, probably, I want you to understand the conceptual model of the make file, but like, what's the logic of the make? How does it know to recompile something? The thing we've asked it for, it sees is it older than the things it depends on, and so it knows it has to recreate it. If it doesn't exist at all, it knows it has to recreate it, right? But if it's older, if it's newer than everything else that already exists, it's fine. That I really want you to know, and I want you to know it does that recursively. So in other words, it says, oh, this thing depends on this other thing. So, the program depends on the .object files, and the .object files depend on something else. So it's going to do it recursively. So it knows, okay, if a .cc file, that means the .object file has to be updated, and that means the program has to be updated, right? So is the program up to date? Well, to see if the program's up to date, first I have to make sure or better yet, put it this way. You have a request, make this program up to date. Make factor. And to make that, it first has to see, okay, does anything have to be done for that? Well, does anything have to be done for the object files it depends on, right? Does anything have to be done for those? Well, let's see what they depend on. And they depend on CC and .h. Does anything have to be done for them? Oh no, those don't have rules associated with them. So they must just be files that compare the dates. And it all works recursively. Are people comfortable with that? Okay, that is absolutely key. So I do want these macros, in make files, and I do want .phony. What .phony? What is .phony for? What do you use .phony? Yeah. Yeah, .phony allows us to say things like all or clean, for example. These are not files that need to be checked. We don't actually, when we say make clean, we don't have to see, oh, is the clean file up to date, or is the all file up to date? They're commands, they're tasks. And so we say .phony them, and it doesn't check on this. We have a file called all that's really recent. It doesn't stop it from working and that sort of stuff, right? .phony. And then there's this unholy thing, which where it makes it just knows about C. I'm not going to test you on that. I'm not going to inflict that on you. So you're not responsible for knowing that it knows about C and C++. Causes me some discomfort to even show it to you. Okay, so those are some things, right, about make files to keep in mind. Questions about that before I begin my stream of consciousness some more? Okay, so I can continue? Sort of muttering? Okay. Great. Just glancing at some things on here. Yeah. So nothing else. Ooh, yeah. Okay. So that was about modularity and contrast. We already kind of talked about that. I'm glancing at some of these other things. Oh yeah, yeah. Coverage testing. What's coverage testing? Mm. Mm. Okay, so that was part of systematic testing, and this is also part of systematic testing. So that's good. Good. The systematic testing. So equivalence class testing, figuring out sort of the broad sets of things. Remember, like, okay, it asks you to enter your name. Maybe you want to give it some legit names, right? Maybe you want to give it a sort of vanilla John Doe. And then you want to give it John Q Doe. And then you want to give it John Quincy Doe. And then you want to give it John Quincy Doe Jr. John Quincy. And that's kind of a different equivalence class of sort of names with these addition things. Maybe we'll also give John Quincy Jr. Esquire. Something like that. Maybe we give it, what's another one that would be sort of a, what would be one that would be another whole equivalence class of sort of similar things? Hyphenated class, great, exactly. So with hyphens. How about with apostrophes, D'Angelo or D'Agostino or something like that, right? So with these sort of these characters that aren't normal alphanumeric, so you might do something like that. Someone with 4 names or something. Okay, so those are good. What other types of equivalence classes or boundary cases might there be? What's that? Yeah, it's blank, right?
Or even just random characters.
Okay, sure. Star 37, something like that. So yeah, that could be random characters. How about non-English characters? Some of my students do something once brought me a program. Go at it. So I think it took about 30 seconds for me to grab some Chinese and paste it into it and crash. Done. and so, folks, there's lots of people around the world and they use different languages. In fact, there's a whole diversity of languages here in the country, and you want to test your program against a diversity of languages and scripts. Some of which are written right to left, some of which are written left to right. So there's a whole set of things there. Empty is another one, right? You might test it with extremely long strings, right? Those are good. If you have, square root function we talked about, right? Positive perfect squares, perfect squares. Positive values that are not perfect squares, 0, 1. Those are each sort of special values because they're exponents of the square root operator. You take their square root and you get the same thing back, right? And then you give it negative values. Those are things that you want to see how it handles, right? Good. But I actually talked about coverage testing. Does anyone remember what coverage testing is? I have some slides up here. Yeah, exactly. Right. So it's another aspect of systematic testing. So the testing carefully, systematically, sort of what needs to be done. With coverage testing, what we're trying to make sure is that we hit a bunch of types of things. Now, the types of things we try to hit are different in different cases. So sometimes we want to hit all sides of a branch. So we have if statement, and then else, and we want to make sure that we hit both the consequent thing that's under the if and the thing that's under the else. Thing that's be executed if it's condition is true, and the one next to the condition is false, right? You comfortable with that? That's one type of testing. Another type, we just want to be sure we hit each statement in the program. We want to be sure that we hit it once. Now, these are different. I could ask, if, is male or something like that, and have this special condition here, and then some more statements out here. So I'll put this on the screen for a remote audience. So if we had, if is male, by the way, that indicates, what does that is connote to you? It indicates it returns a Boolean. Yeah, that's a Java convention, okay? So if we had this sort of thing, so we had code in here and code not here. Statement coverage of all statements would require that it execute what? What two tests would, or what single test would actually handle statement coverage here? It's just true. It executes all the statements in the if, and then all the statements after the if, right? It's hit all those statements. Is that branch coverage? Is that getting all possible branches of this? No, because there's one branch where this would be true, and that's executed, one where it's not true, and so it doesn't execute. And you can imagine, this could be important, because maybe down here, there's a star p equals foo, right? Or star p equals whatever you want to set it to, equals q. And maybe p is initialized inside this if, right? P's, malloc or something like that, but maybe p is originally set up here to null. Do people understand that if we go into this if, well, again I'll type this for our remote viewers. If we add something like this, p equals malloc inside of it, and we had an initialization of this char star p equals null up top, people understand that if we don't execute the body of this if we don't execute this, we call consequent. If we just fall through, we don't execute that because the condition is false, then we'll have a bad situation here, right? We'll have a bad situation because we'll reach this code down here and p will be null. And bad things will happen. We'll try to write to a null pointer. Okay? Are people comfortable with that? So here, testing with statement, modifying the wrong thing here. Testing with statement coverage is different than testing with branch coverage. That's the key thing to recognize. People comfortable with that? Okay. But in both cases, basically, you're figuring out what are we. And by the way, is branch coverage total? Does that guarantee? If you get branch coverage, is your program guaranteed to be correct? Maybe. One of the things maybe is to use this here one with requirements may be off, but even more so, there can be plenty of bugs in there. It may take a special user input. You test it with empty name or something. Well, you test it with a name with an exclamation point. I mean, who knows what sort of thing? And it's not guaranteed just because it has one time where it went down the if, the consequent of the if. In other words, it tested with a true condition, a false condition. That doesn't mean it tested every possible input. But ladies and gentlemen, I mean, if you haven't even tested a case where if is true and if is false, can you stand before me and pass the red? Can I stand before someone and pass the red base test and say, I've thoroughly tested this program? What? You thoroughly tested that? You haven't even tested it if it handles women properly? And is males as false? You haven't tested that? How can you say you tested this thoroughly? So it gets you to a certain level of base validity, in testing, if you can at least test all branches. It's no fancy, it's not a silver bullet, but it eliminates at least a lot of obvious bugs that would plague you, right? This sort of case where the pointer's only initialized with one path, one side of the if and not the other. And there's a lot of bugs like that. So when I was working on the Excel was given the job of doing branch testing on the core Excel routine that recalculates spreadsheets, because in every single branch division. And that's not trivial, because you have to make each one, design a little test case that would make this branch go this way, this branch go that way. I think we may have to do a combination of two, not just every one. But that was a basic faithful. Okay, so that was stuff on coverage testing, and perhaps not easily remembered. I do want to emphasize this. Where can we do coverage testing? I've just been talking about a statement level. Is that the only place we can do it? Could I do coverage testing on other systems without looking at the code? Could I do coverage testing on a teller machine, a bank machine? Yeah, I could. I could make sure it handles. I could test that it's working properly if I enter a wrong number in it, or I enter an invalid card and I enter a valid card. I can see, make sure it responds properly if I try to take out money when there's not enough in my account, as well as when there is enough. I could see what happens if I request a printout of a receipt and there is paper and there's no paper. I can do that sort of testing. It's not just statements. It's not just this low-level code. It's also exercising the broad functionality of the program. And again, could you look someone in the eye and say, I'm going to sell you a bank machine, and I've never tested it under the situation where someone tries to withdraw money and there's not enough money in the account? I mean, you're going to sell this to a bank. You haven't tested that case. I mean, that would be pretty rich. Especially if it let you do. Well, that's another matter. So the bank would not be very rich if it let you take out money when there had no money left. Folks, I mean, you can do this sort of coverage testing, thinking systematic testing. You can do it for code. You can do it, at the level of individual Java or C statements, and you can do it at the level of the system. Does that make sense? Okay. So, who has questions, and who would like, or would you folks like me to continue my stream of consciousness? Yes. Yeah, for the user interface. Yeah, for the user interface. It's sometimes it's called. There's a formula called black box testing. So when I was in high school, I had friends who were hired. They were called breakers, and they were hired to test code black box. They weren't developers. They didn't see the code actually, but they were given a system and told, try to break this thing. Try to get it so it doesn't work properly. And actually, sorry, they're called pounders. Pound at it. Let's give it something weird here. Let's see. And by the way, debugging like that can be. Do you folks want a story? Okay. So one of my colleagues upstairs, Terry Robot, he was here. Did anyone know Terry? So here's a really unique guy. He is a unique guy. So he's he taught computer science here from Regex, including security. But he's also a constable. So he's a policeman, he's OSD. And he was involved in campus security for a lot of computer investigations. Among other tasks. And he told me about one debugging issue, which reminded me of some stories of my own, but this is particularly evocative. So how many people here have been to one scale? Okay, so fair number of people. So if you go up to one scale, I don't know if they have it now because they went through a major renovation a couple years ago, but there was this thing called Buffalo Hunt game. Did anyone play Buffalo Hunt there? Yeah, they had a little video game. You could play Buffalo Hunt. It's like, you want to hunt the buffalo, what strategy do you undertake? And you go and you say, I want to take a bow and arrow, I'm going to take a spear or something like that. And then you go and you walk. And I don't know about all the game. Anyway, they built this game for one scale. Okay? He and his buddy or something programmed this up. And they sold it to one scale. And one scale bought it. And they deployed it. And it was right in the stuffed animals and kind of these some taxidermy, and they have sort of illustrations of traditional crafts and actual arrowheads and stone tools, and they have you know, buffalo skins for people at work. And they actually have a structure. It goes in some by the name wigwam in some areas, but it's covered by buffalo huts, and you can actually go in there. So it's nice and warm. But anyway, so they have this thing right there next to the structure, and so they launched it. It seemed to be working great. People tested it. It seemed great. So they went back to their company, and a day or so later, they got a call. They said, you know, the system is it's not working. That's weird. Go check it out. So we went over there, and yeah, it was frozen. Frozen, it's not working. So he rebooted it, and then he went and he did a log or something of it. That was a great log your system, see what it's doing. Couldn't log it wrong. And so he went back, and basically I'm compressing a long story into a few sentences here, but we kept on going back, and he kept on getting calls. It would be like sometimes we half a day, and it would crash again. And he would try to reproduce these things back in his company. He could never reproduce it. It would run days and days and days, no problem. They'd use it. They'd let it sit. Couldn't crash. Could not crash. And they were getting calls like every half day or every day. You know, it's again, and they're getting embarrassed. They think they sold them up the river. So he was wondering, you know, what in the world is going on here? And they wanted to actually watch how people use this system, right? How do they actually use it? When they went over and had the staff use it, so finally they just decided, okay, we're going to go sit there throughout a day. Because, you know, they have visitors come up and use it, and they can see it on. Okay, we're just going to sit there. I mean, it crashed in like every half day or every day or two. So we're just going to sit there and watch. What's going on? So they kind of made themselves inconspicuous. There's a really big guy, so it's not hard to be conspicuous, but maybe he sat in the wigwam. I don't know. He tried to make himself inconspicuous. Looked like a diorama. Or CMPT or something like that. Trying to make himself inconspicuous, and so they sat there. Nothing happened. People playing the game. So. And then another group came in, walked around, and went over and saw the wigwam and commenting on how thick the hair was, the buffalo hair, and then went and played the game and froze. and so Terry said, okay, so then of course he went, and after those folks had cleared out, and they went to reboot the machine, he went up to the buffalo hair and rubbed it, and then went to the game and boom, cracked. So sometimes you have to think beyond the computer. The world, we live in an analog world. And testing all paths wouldn't have helped there so much as testing all physical paths among the wigwam and stuff like that. So anyway, story told. Moving right along. Let's see. I was in the middle of an unspecified activity. So coverage testing. You can do a fair amount with automated testing. Sometimes you need to watch people. Okay, yeah. So I talked about black box testing and this thing like equivalence partitioning and boundary values. We talk more about this in 371. So those will see more of that. More sophisticated techniques like orthogonal arrays, etc. Right. What is the thing called? Test. What is the mechanism called that controls sort of testing through program? Tests your program, sets your program up for testing and runs tests on it. It's called a test harness or scaffold. So gets your system ready, or pieces of your system ready, right? Sets them up with the right data structures inside. Sets it up with a proper hash tables and hash tables.
Do something about that.
Yeah. So like a dictionary.
Yeah.
It looks up keys and gives you value. Yeah. So you know maybe your thing to work properly has test harness might, go and read it from a certain file into a nice long array and stick it into this other place and give it as an argument. Or maybe it goes and creates a file on disk that has some corruption in it in a certain way and sees if your thing will fix it or will deal with it gracefully. The test harness is sort of the thing that's responsible for getting things ready, sets up that ball, and boom, you can test it and see if it works. And we talked about, there's actually several levels of testing that go on. One is, what's the lowest level of testing? Okay, good. Good. You comply. Yeah, you can think of that as the lowest level of testing. That's great. Compilation, folks, sometimes you have an adversarial relation. But compilation is a process that can help you find out. It can help you find out. Particularly for higher level languages. And C, it's limited to what it can do. Because C is so loosey-goosey. It allows you to do these sort of things. It just says, yes, ma'am. And does what you say. Higher level languages like Java, Scala, they'll actually do a lot of testing and say, no, it doesn't add up. They'll warn you about it. They'll warn you about it. They'll say your if statement is an int in it. It doesn't have a boolean. You said if A equals 1 instead of A equals 1. That's an integer. If A equals 1, assigns to A, it's an integer to A. They'll say, no, that's an integer. You can't have if with an integer. You have to have if with a boolean. They'll do stronger tests in your program of many sorts, many sorts. And it will warn you. They'll say this doesn't compute, doesn't add up. No. So compilation, even more so than in C, is very, very useful. But in C, it also helps. What's the next level up of testing conceptually from that? Sorry? Oh, is it correct? Well, yeah, but actually, what we start with, and I have this diagram I actually drew up, and it's on the screen for those who are remote, is this so-called V diagram associated with the test. And what you have is kind of unit tests being done. Okay? This is kind of low-level coding. These are like individual functions, something like that. And you have unit tests. This works really, really well when you have separation of concerns. You have your program divided into pieces. In the ideal world, they should be no more than like 9, 10 lines. Maybe you're really pushing it and there are 20 or 30 lines each. Please don't give me lines of 100, 200. File one follow function. Low-level coding, we do unit tests on it. And we typically try to test it in isolation. So we try to test foo calling a stub, rather than testing foo and bar together. We first get foo calling a stub. We test bar by itself. And then we get foo calling bar. That's called integration testing. And trying to make sure, it's trying to use similar terminology here. Detailed design is it's called integration testing. So how things need to work good. It needs to be consistent. Maybe the person who wrote foo was perfectly reasonable about their assumptions. Maybe the person who wrote bar was perfectly reasonable about their assumptions about how something would be coded. But they make different assumptions. This is how you figure that out. They have to play together. They have to coordinate. They have to play nicely together. They have to be consistent. You can use different terms for it. The point is that they integration test, system tests. I'd like you to know something, that there's this notion of stubbing that's useful to do true unit testing, eh? And then there's and often we in this class we focus more on the unit test, but just be aware things are logging. Logging is a great thing. Oh man, writing out what you're doing, especially for high-level things, and some frameworks like Log4j that you may be using next year, they allow you to write out logging information at different levels and basically change dynamically. What do you mean by dynamically? Change dynamically what level of logging you do, what types of levels of information you put out. What do you mean by dynamically? Yeah, it's actually sort of while the program's running, like while it's going on, not just statically, which would be like having to recompile all ahead of time. Instead, dynamic is changing it while the program's running. In the midst of it, you could say you can flip this switch, and suddenly it's going to be outputting more detailed information about what's going on. You can flip the switch back, and now it's just going to be outputting things like, oh, I'm connecting with the database, oh, I'm opening this file, oh, I'm closing the file. Things that are very high-level operations. Okay. So those are good. grep. Yeah. Grep. Oh, yeah. So, this is getting us back into sort of command issues and so on, and early on. But there are some things that I wanted you to know from that discussion of sort of command combination we had there on the last day. So if I want to have a program, foo, take input from a file, take its input from a file into its standard input, how do I do that? Yeah, so I do less than some file, right? How if I want program foo to pass, to take its input from another program? Yeah, so I can create a pipe, bar pipe to foo, right? Passes standard out for this, standard input for that, right? What if I want to have the standard error from foo go to a certain file? Yeah, to into some, errors file, right? What if I want bar to give command line options to foo? We talked about that in the last day. Yeah, back quotes, right. So we could have foo. I really need to write this down for our broadcast. Could have it something like that. So now bar is executed, and it uses these as the arguments now to foo. How if I had foo? How if I had bar and then semicolon foo? What will that do? Yeah, bar and then foo. Sort of no direct connection. Of course, this guy could output to a file. This guy could read from it, but this guy executes bar, but executes before foo. Pipe, they execute in a what sort of way? Sorry? Yeah, it's like a bucket brigade. I deal with the first line and pass it to the person next to me, and I go on to the second line, and they're working on the first one, third, and it's just going down there and all going together. Very different from DOS or Windows command shell, where that first guy foo has to execute entirely. So you can do this pipelining actually in Windows command prompt. But bar has to complete before foo starts. Okay, quite different because among other things, in some Unix utilities, like the yes utility, there's no end to it. It just goes and goes and goes and goes. And that's fine as long as if the second one completes, you know, it'll be done. But here in DOS, you know, bar foo will, if bar goes on forever, foo will full. The whole thing won't complete. So I'm just putting some things that I put up on the board there. There we go. So those are some ways of combining. Oh yeah. So stream of consciousness. Forget my non-linear jumps here. There are some things I do want you to know about some command line options about things. Like one of them would be so the make has a minus m, minus cap m. Oh, sorry, minus w, minus cap w. What does that do? Yeah, exactly. What's another way that you could sort of make something seem that you could sort of artificially get something to compile? You do what? You touch it. Sorry? Yeah, make minus, yeah, so make minus f allows you to specify the file. Make minus m, n? Oh, minus n will run the make file and record what would be done without actually doing it. Pretty, wait, I'm sorry. There is a make option. How is make minus n, but I may be wrong. In any case, there is a way to get make to kind of tell it what it would do without actually doing it. And that's useful. You're talking about the touch option?
I think there's some option you do minus and you get word exactly like touch.
Okay. Well, there's the minus W, which is a lot like touch. It actually forces it to you know, as if it needs to do this. So that's worth knowing about. With debugging, I do expect you folks to know that if you compile the program to work with the debugger, how do you do that? Your GCC, that's the thing. Probably is good to know about GCC minus C. I don't expect that. What does GCC minus C do? Just compiles it to a .o file, right? That's a good thing. How about the minus L flag? Minus L X, or the X is a character. Yeah, it can link it to like a math library or a character library or what have you. I don't think I'm going to go into that sort of work now because you can look it up with. You can look it up with what? Name. Thank you. Thank you. So those are good. So anyone want to ask questions before I continue my stream of consciousness? Because tempus fugit, time is running on. And I want to make sure people's questions are answered. Yeah. 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 Right. Yeah. So there's actually this is a good point, and it brings home something I do want you to understand the distinction between. So I do expect you to understand SVN status as a mechanism. What does SVN status do compared to SVN diff compared to SVN log? These are, oh, that'd be a nice question. Okay. Good. Or if there's a conflict, for example, that needs to be resolved, right? So those are indicating SVN status. So it shows for each file what the status is, right, associated with it. How about SVN diff? Yeah. Yeah. Yeah, if it is syntactic. How about SVN log?
Well, I mean, if you use the verbose, it shows what files are being changed,
That's right.
as well as when the rest of the like,
Right. That's right. So associated with the minus m parameter that you entered to sort of give indication of what you changed associated with things. So to answer the question earlier, so you do an SVN commit, and then you do an SVN update. What's the SVN update doing? Yeah, bring it into sync with the latest version, the head version. And that's an important concept. I want people to be, if I say the head version of the repository, that's kind of the latest snapshot of the repository. It's kind of, right? There's some latest snapshot. Maybe this person was working and checked in something on the branch, on a certain branch. Someone else checked in something on the trunk. Someone else checked something in, in this other branch. Yeah. That's the latest one. Some resulting sort of state of things in the repository of the very latest. We call that the head. The head. It's the sort of revision that's the head. And if we do an SVN update, it kind of syncs us with that head. And it's with that SVN log that we can, it's with that we can get the sort of SVN log information associated with sort of the set of changes and so on. So we need to sort of resync with the repository in order to get this full accounting of changes that are required. I don't know if I'm explaining it sort of in the way that you're needing, but yeah. Yeah. Indeed, because you hadn't updated. Yeah, you have to know. It's a little bit of a ritual, isn't it? I mean, you might think that SVN commit should just do that, because obviously that seems to be your intention, right? But it does require that little ritual, sort of resyncing with the head, because it's not always the case. Like if it automatically did it when you did an SVN commit, you might there's some good reasons why it doesn't sync you with the head when you do an SVN commit. Why wouldn't it sync you with the head? Why wouldn't you want to always be synced with the head when you do an SVN commit? It's actually that there may be some files. So you may have committed the things you've changed, but maybe you have some old versions of other people's files that you still want to be working with. And so you don't want it to go update all of them. So conceptually, they separate that notion of doing the commit of your changes and that update to get other people's changes, right? Yeah. Right. I think, and that was one of the problems that I had with doing Live 11. It really would have been nice if we could have a remote, like a server, and maybe you could do it with a buddy and one person updates and you can see the other. Because with one person, it's a little bit, kind of pushing the imagination. But we do need the tech stack to set things up. Later, you folks will see Git, and it'll be a lot easier to get a repository to sort of see what's going on, because anyone can set them up and so on. Okay, and you can share with them. So, okay. So, any other questions that I could handle before I go into a little bit more information, getting back towards the beginning of the term? Yeah. Sorry, make capital W can be used to basically force it to undergo a certain make rule. So it's let's suppose that you Okay, so normally if you say like make all, right? It will look to see does this need to be done, right? How will it judge that? How will it judge whether it needs to be done? Timestamps, yeah. So look at and whether it needs to be, whether it exists at all, right? The requisite possible time. But you can force it. So it might, you might say make all and it says everything's hunky-dory, everything's just fine, right? But what you could do is you can force it, essentially, to treat it as if something's been updated, okay? To force it, to get it to kind of, to make things. Okay? As a target, I think it can be a target. I don't think it has to be a file, but I'd have to go check that. But basically it's a way of kind of forcing it, because sometimes you know things that it doesn't know, and like maybe what you've got on your machine, on your machine, maybe in your working directory, maybe what you have is a copy of the program that you got from someone else just recently. So it has a later timestamp, but you know it was built with an older version of the code base, and you want to actually create a new version, new version of that, and it's saying it can't because it's later than the files it depends on. Well, it may be later in timestamp than the files it depends on, but really this is just from someone else's machine and happened to have that late timestamp. Really, it needs to be remade, and so you can force it to do it with minus W. Does that make sense? Okay. So that's good. Other questions? Gosh, there's always these things. I always feel like I'm giving out secrets. But that's what I like doing. And sometimes I find that the secrets don't give away the whole show. Well, it gives away a lot, but then maybe if you folks have taken notes, you'll be in very good shape. I sort of consider some of the biggest things, but if you've paid attention, you're going to get a lot. Okay, so grep. Well, what does this thing do? What does that thing do in a command line? In a command line, sorry, not grep. What does this operator with less than do? Well, yes, exactly. So if we said like grep, foo in, foobar or something like that, it would find foo in this text, right? That's one way you could test it with a known element. We talked about regex. I don't think we need to go into them in detail here. Do you need me to explain anything about regex? Does anyone have a question about regex? Oh, yeah. I'm gonna go here to this. Right. So I think what you're talking about. This thing? Yeah, so there are several things that are sort of relevance here. Like \cap w indicating a non-word character, \w, lowercase w, indicating a word character, and this indicates here, this \angle bracket indicates the sort of the beginning of some word. So it's kind of saying, okay, off in this area, there's something that's not alphanumeric characters. It's something that's not a word. It's not part of a word. And I think it's alphanumeric. It may include the underscore. I'm a little bit vague on that. And similar, there's this backslash greater than sign to sort of say, okay, there's things over here that are not. You can do a lot of similar things with, you know, these sort of operators. This will match a whole set. This is backslash lowercase w. Will match plus. It'll match a whole bunch of word characters at once. And backslash cap w will match a non-word character. Okay. Yeah, I can't speak in, that's in sed, right? Yeah. Yeah, I'm not sure. Backslash b, right? Yeah, I can't speak to that. I don't happen to remember exactly what that is. What I can guarantee you is it won't be on the file. Yeah, yeah. But you know, I admire you going and finding it. There is of course $sign. So I guess I should have listed. What does this mean? End of line. And how do we indicate the beginning of the line? Caret. And remember, caret can carry a special meaning in extended regular expressions in what context? Yeah, you can say not one of these, not a 0 to 9 character. Each little regular expression thing, I'll get to you just a second. Each little regular expression, a dialect, like tool has different regular expression dialects, and some like backslash d use a digit, for example. And you can use it to match. Yeah. So this, oh, no, so great question. So the question is putting a caret in square brackets, the same as the first character. It has to be the first character in those brackets, by the way, to get 9. Is that the same as putting it in round brackets? No. With round brackets, a caret means a caret. Sorry. Round brackets, it wouldn't mean not. It's not at the beginning of the line. I think it will get confused. I think it might exhibit dysfunctional behavior. I don't know if you mean something like that. But it does not mean not there. Because in brackets, in round brackets, it's so what we call parentheses. It's just matching things one after the other. The not particularly means that it's none of these. None of those. Okay. So great question. Any further questions on this? The time is ticking because I'm supposed to meet with students about a student project thing after this, so I can't keep them waiting too long. But I think I'm supposed to meet them at around 8:15 to 8:30. So let's see. Are other questions? I keep on stream of consciousness, but I think you kind of know some of the things I think are important for the earliest pieces. How about grep minus I? Case insensitive. Yeah. How about grep minus L? Print out files where it matches. So just print out the file names. Pretty sure it's minus L. How about grep minus E? Yeah, extended regular expressions. I'll tell you something, folks. And this is personal practice. I don't pretend it's an inherent thing. But personally, I really don't. Forgive the double negative. I really dislike not having extended regular expressions. Regular expressions, I want them every time because I find the other syntax is atrocious. So I want extended regular expressions every time. I'm unlikely to give you stuff that like throws you not unextended regular expressions. You know, like where you have to do backslash begin paren. I mean, that's. To me, that it looks very ugly. How about grep minus V? Yeah, exactly. Shows the things that don't match the thing. So that's really good. Excellent. So I'm just looking here. Well, if you went through that little regular expression tutorial, if you're feeling confused about it all, you could look through there. What do these curly brackets do? How if I say like, you know, a backslash, backslash F, you know, S, and then, you know, 1, 3. What does that mean? Yeah. Sorry? Exactly. Let me ask this, folks. So this is just a little test. Suppose I did dot, you know, 3, 5. I'm gonna put up some regular expressions. What did the dot mean? Okay, good. So how if I put up A? Would that match? How if I put up ABC? Would that match? Yes. You have to be very careful about this. This is not saying it has to be the same character repeated 3 times. It has to be, you know, one of these guys or gals repeated 3 times. So it's like having dot, dot, dot. Well, it can be a dot, 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 or it can be dot, 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 or it can be dot, 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 dot.
How would you get the case?
Sorry?
How would you get the case for that?
So if I wanted to match AAA, but not ABC, is that what you're saying? If I wanted to match AAA, but not ABC, what I would do is what? Anyone? Sorry? Yeah, so I do a back reference. So I'd do a dot inside parens, and then I do \1, \1. So I could do, if I wanted to force it to be the same thing every time. Oh, sorry, 3 to 5 times. Ooh. So you wanted 3 to 5 times, right? Yeah, sure. Okay. I don't like it, but it ain't pretty, but it gets the job done. Watch this. So dot inside the parens, right? And then I can do, okay, this is actually an interesting question. One thing I don't know if it will work. Well, I'll show you how it definitely works, and then we'll see. I'll tell you one thing I don't know if it will work. I could do this guy, or, ooh, this will have to be 2, because I use this, I'm using this or it could be, oh gosh, that will fix it. Okay, so it could be this, or \1, \1. You know my habits. Okay, gosh, this looks like I'm running a cuneiform or something. Or so that, sorry, this is 2, so this is 4 of them, and now I need the one with 5 of them. Yeah, I'm separating up each case, divided up with these pipe symbols. What do those pipe symbols mean here? It means yeah, just or you know, you could have any of those. That will actually do it, ladies and gentlemen, but it ain't a thing of beauty. What I don't know will do it would be if you had this. This is what I just don't know. Could you have dot \1 and then you say 3? It would be 1 to 3, right? Because you've already got 2 of them. Oh, sorry, no. This would be 2 to 4. Because you need sort of 2 of these along with this original one up to 4 of these. I don't know if that will work. This is a big question mark, and that's not a regex operator for this. It's a question mark whether that will work. So I'll put it in front. So I don't know about this guy. This guy will work for sure. You've got, these are \1, \1, \1. That will work. What are those referring to? Sanity check? \1, they're referring back to this guy here. You've got these parens around it, but because this is the first, it's going to be fine. Okay? Okay. Any final question before I turn into a pumpkin?
Can you post the link to the video?
I will most emphatically post this link to the video. And I wish I could post the link to the board, but alas, the technology is not. They've missed the pointer arrays and the fullness of pointer arithmetic, which I regret. Okay, any further questions? Final question? Yeah? I haven't decided fully yet. What I do know is this, and I've told people this. I have extremely stiff deadlines for getting this exam back to people. Okay, they start really going after me if I don't have it back soon. The class is over 90 students. Only I can mark the exam. And I have to go, so that means I have to go through every single one. And commonly when I mark an exam that is a full 3-hour exam, so a final exam, normally it takes me between 45 minutes and an hour each student to mark. And I've been marking this over my holidays. So we're talking about 90 hours of marking